Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to finally implement some shooting mechanism for our player. We are actually going to do two things. The first is we are going to actually implement the UI for the player to look at the first person weapon, much like if in Doom and the original Wolfenstein you could see the weapon as a 2D sprite on the screen. And then we are going to actually implement the shooting mechanism for doing raycast, and for that we are just going to refactor our code a bit. So firstly, let's go here, and you can see that I have got this weapon.png image here, which is just extracted from the Doom one. It's just like the shotgun image with the transparent background. So we are going to actually use this. So what I'm going to do is first of all, let's go ahead and go under game.h. Now in game.h we have got a texture here called weapon text, and the reason that we have got this in game is because this is actually separate from the standard sprites. It doesn't have a fixed size, it's different. So I just decided that we might as well do it inside of game. And if I go under cpp, game.cpp, you can see that in the constructor we just load it from the weapon.png file. And when we are actually drawing the game, what we do is we construct a sprite based on that texture, set its origin to half size of the weapon on the x-axis. However, on the y-axis we do not set it to the half size. That is because since we are doing this as a first person thing, so we want this weapon to be displayed at the very bottom of the screen. That is, the weapon should end at the very bottom of the screen. So we don't want this to be centered, we actually want the origin to be at the end vertically. So that's why we pass the whole vertical y size to this set origin function. And then we set the position. On the x we just take the x and divide that by 2, and on the y we just get the size of the window on the y. And the reason we divide it by 2, of course, is because we want it to be horizontally centered. However, on the y we obviously don't want it centered, we want it at the very end. So here we pass the y size of the window. And now the actual image is pretty low resolution, so we actually use set scale to set it scale to 2.5, and you can choose this value according to what you like, but 2.5 is generally what I thought was kind of the correct size. And then we just use window.draw to actually draw this weapon here, and this is just drawn like a 2D sprite, nothing any complicated here. So if I go and run make, you can see that we've got our weapon here. It looks pretty awesome, I think, and you can see that it kind of looks like the first person weapon. Currently, of course, it's just a static image. We could make it animated, but for now it actually does work. So yeah, that's pretty awesome. So now to actually allow the player to shoot this weapon, I am going to go ahead and open up player.cpp, and in here you can see we have got the functionality for actually shooting this. But before we do that, let me open up a new file called raycast.h. Now our raycasting code currently was in the renderer. However, we'll need to separate the raycasting code from the rendering code because we want to use the raycast in other places. So we have got this new header here called raycast.h, and in here we have got a structure called rayHit. Now this just has an integer cell here along with a vector 2i for the map position where it got hit, along with a bool representing whether the hit was vertical, and a perpendicular wall distance here. All of the stuff that we basically need for our raycast, we have got this here. And we have got this function called raycast, which takes a map, of course, and then the position and the direction of the ray, and then a maximum value, which is by default 64. This is the maximum number of cells that the ray can traverse, and in the end it just returns a ray hit structure. So if I go ahead and open up raycast.cpp, you can see that is basically the same algorithm. We just return all of the data in the form of a structure instead of using it to do a wall here. So it's basically the same DDA algorithm that we were using earlier. Now if I go ahead and open up render.cpp here, you can see that instead of having the whole DDA algorithm here, we just use raycast to get a ray hit here. Ray hit is equal to raycast. We give it the map, the ray position, and the ray direction, and then we check the hit cell, and we use the hits is his vertical and perpendicular wall distance everywhere, and the rest of the code is pretty much the same. So what we do in player is that if the mouse button was pressed, we check if the player has not just fired. We've got this static boolean here. Static means it is not reset between function calls, basically static storage. So we've got this just fired here because we don't want this to be like automatic. The shotgun is not automatic, so we want to make it so that if the player has just fired, it will not fire. However, if the player actually doesn't press the mouse button, which means the player releases the mouse button, we just set just fire to false. Anyway, so if the player can shoot, what we do is we use ray hit, and we just use raycast to get the hit, and for the position we just pass the position of the thing, while for the direction we just pass this front direction that we have calculated here. And the next thing we do is we check if our hit.cell was hit, and if it was hit, then we go ahead and just print that hit wall at this position. So we just do that, and if I go ahead and run make here, what you should be able to see is that I can go here, and this, by the way, only occurs when we are in the game mode, as you can probably see. So if I go ahead and go to the game mode, I can left click my mouse button, and you can see in the console here it actually says that it hit the wall at 310. You can see it says that here, and if I actually run this again, you can see that I can go ahead and try to shoot at different walls, and it actually gets all of that correctly, which is the expected behavior. As you can see, if I shoot here, it's 0 1, it's actually 1 0 here and 0 1 here. So of course this works against walls, however it currently does not work against sprites. So we need to kind of make our algorithm so that it also works against sprites and things in the world, so that we can actually hit this monster or this pillar, for example. So that is going to be a pretty interesting to implement thing, and that is what we are going to do in the next video. So stay tuned for that. Make sure to like and subscribe so you don't miss the next one. Make sure to share this video with other people as well, and I'll see you in the next one, and bye.